Hello, my name is Isabela Drămnesc and I am a teacher at the Computer Science Department of Faculty of Mathematics and Informatics from West University of Timișoara. Now you are attending the Graph Theory and Combinatorics lecture related to spanning trees. We have to solve the following problem. The North Carolina Transportation Department, NCDOT, decided to realize a fast railway network between 8 cities from west of the state. And you can see on the map, you can see the cities which are marked. Some cities are already connected by roads, and the plan is to place railways beside the existing roads. Different terrain forms imply different costs to build the rail connections. The objective is to build the railway network with minimum costs and to ensure the connection between every two cities. This department employed a consultant to compute the construction costs of the railway network. And he derived the graph which you see on the right-hand side. This graph contains 8 nodes, 1 node for one city. And he took into consideration only the existing roads between two cities. So he drew one edge between two nodes only if the road exists. And he placed also on each of the edges the corresponding cost for building the railway beside the existing road. Now we have all the necessary information, so we have the graph, and let's remember what are the constraints for building this railway network. First, we have to ensure the connection between every two cities. What does this mean? This means that we need a connected graph, and in order to not have more roads than necessary, we need a graph without cycles. Now, we all know that a graph without cycles is actually a tree. And a tree, which contains all the nodes of the graph, this is called a spanning tree. Second, we have to ensure a minimum cost. In order to do that, we wish to obtain a minimum spanning tree, and this means that the sum of the costs of the edges of the minimum spanning tree has to be smaller or equal than the sum of the costs of the edges of any other spanning tree of the graph. And here you can see 3 examples of spanning trees which are derived for the corresponding graph G. Each spanning tree actually has a different total weight, and what we have to obtain is a minimum spanning tree. In order to find a minimum weight spanning tree, we apply the Kruskal's algorithm, which states the following. Given a connected weighted graph G, first, find an unmarked edge with minimum weight and mark it. Second, choose such an unmarked edge with minimum weight and mark it, but take into account only the unmarked edges which do not produce a cycle with the other marked edges. Third, repeat step 2 until the marked edges form a spanning tree of G. Okay, so now let's apply the Kruskal's algorithm for our graph. First, what we have to do, we have to find an unmarked edge with minimum weight and mark it. And in our graph, the edge with the minimum weight is actually this one. We continue to choose an unmarked edge with minimum weight, and we have 2 possibilities. We have 2 edges with weight 20, so we choose one of them. And now we cannot choose the other one with weight 20 because we obtain a cycle and we don't want to do that, so we continue with The next one with weight 25, and then we choose the edge with weight 30. And then the next one is the one with the weight 35. We continue with this one. And now what do you think? Do we stop? Well, we have to stop when we obtain a spanning tree. This means that we need to cover all the nodes of the graph. So we still have to choose this edge. So now we stop because we obtained the spanning tree, and this is the minimum spanning tree with total weight 210. And this is the solution of our problem. Thank you, and I hope to see you soon in our faculty.